we're going to be building on the code that we made last time. Here I've got it named 2018 Lambert beer code, but you could have it named whatever it is that you want. And I'm just going to build or add to this code. So I'm just going to go ahead and make a copy of this. So save as. Primary production. Okay. So last time it said in this assignment you'll learn how to read in data from the web and calculate underwater light fields, Lambert beer law, and so I'm going to add a note here. We are also going to compute primary production by phytoplankton using the hyperbolic tangent model. All right. So the first thing we can do is we can just come down here and read in our light. Remember, this is the same code that converts it to a plot here. All right. So here's our light. And we're just getting ready to create our depth vector, and we're setting an attenuation coefficient. And now what we're going to do, and we have our underwater light field, which we're going to fill down below with this loop. But now what we're going to do in here is we're going to set primary production parameters. And those are going to be Pmax, the maximum photosynthesis. So we're going to set that equal to 1. And the units here are in milligrams carbon per day. And our EK, E sub k, is going to be set to 50. And this is going to be in units are watts per meter squared. And we're also going to have an EB. It's going to be set to 400 to start with. And the units are watts per meter squared. And R, which is our respiration. I'm going to set that to 1 at the moment. And the units are same as this, milligrams carbon per day. Okay, so we set our primary production parameters. Now we need to create, similar to the way we created a field last time, we held our light field values. We're going to create our primary production field. So this is creating a field that will be filled with underwater primary production. Oh, we can go ahead and copy this, run that new in our code. Get these. All right, so before we ran this and we made an underwater light field. So if we take our loop and run it down to make our color image, oh, length Z not found. I guess I didn't run that. I better do that. I'll just start up here. So that ran quickly, and we'll make an image. That's our light field, and now we need to make primary production as well on this. So let's go ahead and come back in here. When we compute here's where we actually compute light. Here, right underneath, we can compute our primary production. But before we do that, we probably need to, yes, this is it. We got to make, just like we made a vector here, we're going to do a pp.vec, And we're going to start this with, I have my notes here. Start this with an NA. So the just like par was at the surface, we pulled the surface value at the surface. There's no primary production. It's outside the water. We're going to start it with an NA. And so then what we're going to do here is create our, so here's where we actually calculate our UI. Now we're going to create primary production. And our primary production is going to be Pmax times, this is our hyperbolic tangent function, tan h of ui divided by ek times 1 minus tan h ui divided by eb minus r. So we're going to compute that, and just like we create a vector of light, we're going to create a vector of primary production. We're appending what was in the primary production vector with the primary production that we're computing here. Just very similar to what we did with light last time. And then we get the same kind of thing here, except this is going to be PP field and right. Okay. That should do it. And let's see what happens here. When we come up here, let's just start at the top and run it. Okay, so we have created now, we can make, just like we made a image.plot of the underwater light field and contour plot of this. Right? This was from last time, we can get rid of this. Let's go ahead and make a color image of the underwater primary production field. It's going to be very similar to this. We're just going to copy this, paste this here, sun time. This is going to be our PP field. And let's run that. Okay, here's primary production. It looks like it's all negative. The highest values are here. It looks like it's a little lower, then it gets high, and then it goes down again. Let's try to sum PP field. This is going to add all of the values in our PP field together. And as you just would have suggested, it's really, really negative, which means respiration is dominating this thing. Another thing that we can try here, besides summing everything up together, is to go ahead and plot the UI field underscore 1 with the PP dot field. So this is that field. So this is a matrix versus another matrix. They both have the same dimensions. So if I do the dimensions of UI.field underscore 1, it's 365 by 101, and 365 by 101. So every x value here has a corresponding y that we should be able to plot. So here it comes. So this should be the relationship. This is our primary production curve here. So this is low light values, and this is primary production over here. You can see we never really get into positive values over here. But we can make this look nice with xlab equals light and watts per meter squared. And this is ylab equals milligrams carbon per day, right? And the other thing we can do with this, so we can just run this again. So those two things pop out there. We can also make a contour plot. So let's just go ahead and make a contour plot of the primary production field. Okay. Right, okay. So there it is. It's all negative. Let's try plotting the compensation depth, which is where this equals 0. No, doesn't show up because everywhere is below 0. So we can come up here and we can adjust some of these things. Try and let's make a higher Pmax here. Just make it 3. So we can come up here to the very top again. In fact, we can just come up and rerun all the code. There it is. So there's the compensation depth when Pmax equals 3. We're going to go ahead and start with 1 for the exercise. So if you want to save some of these plots, so there's a couple interesting ones in here, you know, something like this, you can always export them, save them as an image or PDF, copy to a clipboard, probably copy to a clipboard, and you can paste them right into a Word document. Okay. So what we're going to do now is I'm just going to point you over to the homework that's associated with this, and thanks for watching.